Thank you, Kinnery. So, hi everyone. I'm Zhefei. I'm a software engineer at Visual Search team at Pinterest. Today, I'm so honored to be here with you, and I'm going to talk about several products we've been built over the past 3 years, which are empowered by computer vision and deep learning and our technical efforts behind them. So first of all, for those who don't know what Pinterest is, I guess everyone knows now, as Ben has mentioned, it's a visual discovery app that people use to find ideas for everything, from what to make for dinner to how to style an outfit. So as for a pin, it's made of an image, text description, and other metadata. So you can browse and save pins you are interested in. Right now on Pinterest, we have more than 100 billion pins. They are all human-curated and categorized by people into more than 2 billion words, which means we have more than 100 billion images for us to build a powerful visual search system. So to build such a bridge from the real world to Pinterest, we launched Pinterest Lens early this year, which is a visual search tool that uses the camera in your Pinterest app to discover ideas inspired by objects you see in the real world. So by taking a picture of your jacket, you can find other outfit ideas similar to your clothes. So we see people using Lens to find fashion ideas, take picture of their homes to find furniture ideas, find recipes by taking picture of foods in their refrigerator. So Lens is so applicable to any object in your life. And today I'm going to talk about brief history of our products, 3 important milestones in our team, and how those products evolved. First of all is visual search. So as Pinterest has a lot of scene images, could be a room with many pieces of furniture or different pieces of clothing in an outfit. So when people see this, they often just care about one item. For example, when I see this image, actually, I just care about this super cute handbag. So I want to know, like, what's this brand or where can I buy it? So we let you crop any pin to do a visual search to help you find info about the item you care about. Let's talk about challenges. As you can see, those red bounding boxes, they're visual search queries from user. They could be any arbitrary pixels and images. It could include multiple objects. As I mentioned, we have more than 100 billion pins on Pinterest. So how do we find the most visually similar pins from the huge amount of pins? So here we illustrate a high-level overview of how visual search works. First of all, we need to find a way to determine the visual similarity between the 2 images. So we train convolutional neural network, which contains multiple layers in the model, and each layer is a different representation of this image. And then we extract the visual feature vector from this image, from the embedding layer, and we do the same thing for the second image. And then we compute the distance between them and get the visual similarity. To train such an embedding model, we first collect millions of weakly labeled training examples. And then we train embedding models on the label data. And then we extract embeddings from trained models for the entire corpus of Pinterest images. And finally, we index those image embeddings to our nearest neighbor data structure for candidate generation. We also done a lot of model research by using different architectures and the different training losses. To find best embedding model, we do offline evaluations on embedding and distance metrics. If you want to know more about our work, please see more details on our paper, Visual Discovery and Pinterest. So next, I'm going to talk about object detection. So one motivation is that we want to build a better user experience so that the user don't need to crop the image. Also, object-to-object matching is much more powerful than image-to-image matching. For example, to find things with exact the same chair, you need to find the chair from the image first. As we have so many pins on Pinterest, we want a best performant object detector to populate objects to user. We investigated 2 state-of-the-art detection models, FastRCN and SSD. We found that the FastRCN, while performing the best overall, was slower than SSD. So we optimized the model by architectural changes and improved the latency by 2 to 5x while maintaining the model accuracy. Also, one interesting area we are currently working on is on-device detection model, which can enable more real-time product experience. Also, to improve the detection quality, we used entropy of visually similar readouts. For example, the bounding box in the left image, its visually similar readouts are quite diverse, such as white pillow, a piece of white paper, even a part of white bridge, because we don't know what it is. So the category conformity score is pretty low, so we suppress such bounding boxes. As for the bounding box in the right, as its visually similar readouts are more about coffee table, wood texture, and they all belong to furniture category. So it has higher category conformity score, and we keep it. Such method improved detection quality and increased our user engagement. So finally, let's go back to Pinterest Lens. At the very beginning, Lens was doing pure visual search. When you take photo of avocado, it would return all visually similar avocado. However, it's not useful. As when people search for avocado on Pinterest, they're actually looking for avocado recipes. What can I make for my dinner using avocado? Then we made changes by combining visual search technology with Pinterest discovery experience and make it much more powerful. Now Pinterest Lens will not only give you visually similar pins, but also semantically relevant pins. So one important product decision we've made is visual similarity is not the goal. Pinterest Lens is the entrance of Pinterest recommendation system and personalized discovery experience. We are also building object-to-scene visual search. We extract objects using our object detector and build an object index. Then we use our index to find visually similar objects and return the whole image back to user. Finally, after talking about those technical works, let's take a look at the applications and how we apply visual search technology to more products. So on Samsung's latest smartphone, the Bixby by AI image search is supported by Pinterest Lens. We also built a product called Shop the Look by connecting detected object to real products so that people can buy it right on Pinterest. Also, by clicking the right bottom circle on any pins on Pinterest, you can get instant ideas inspired by this pin. Such recommendation system is supported by visual search. So as you have seen, we've launched a lot of products. We are continuing to improve our visual search technology to better understand images and our users. And our goal is always the same, to help our millions of users to search and discover the content they love. And thank you for attending our event tonight. Thank you.